Hello everybody, it's Yuri again. I'm here with another home automation project that I have been working on. This time is the NFC reader that can act as a OneWire device, and it emulates DS2401 iButton device. There are three more modes that can be used together with OneWire emulation. The first one is a digital output that sends the pulse when the card is read. The second one is using internal database of NFC cards, and it's using two digital outputs. First one is sent when the correct card is read, second one if invalid card is used. And the last mode is linked to the previous one, and instead of hard-coded NFC cards that are written in your source code, it's using something called learning process, and this allows to write the NFC cards to the EEPROM so you can learn new cards without programming the module. Let's first focus on the hardware part and the wiring. I'm using again Arduino Nano, but probably better choice would be Arduino Pro Mini because of its size. Then you will need to get an NFC reader. This project is based on PN532, so please make sure to get this reader. And the connection with the reader is done using SPI, so make sure that you set up the switches on the reader to SPI mode. You will need 6 wires to connect to NFC reader. 2 of them are for power, so this is ground and VCC. And there are 4 wires for SPI connection. You need to connect them to pins 9, 10, 11 and 12. Then there is a pin 8, which is one wire bus, and then there are 4 digital outputs. These should be connected to the pins 4, 5, 6 and 7, and they are related to the modes that I have been talking previously. And I'm using the LED light to show the outputs. Time to switch to Arduino IDE. You will get the project as always in the video description, so download it, extract it and load it in Arduino IDE. You can read some basic description about the project. Using following link you can buy the NFC reader, and this library is needed to be installed to allow communication with the NFC reader. If you will scroll a little bit down, you will see the definition of the modes. Each of them can be enabled or disabled. To disable it, simply comment out the line, it will be disabled. It's up to you if you wish to use them or not. I will be talking about each of them later on. Let's start with the first one, and this is OneWire simulation. Scroll a little bit down, and here is the definition. You can define which pin should be used for OneWire data sending. As a default, it's pin number 8. This is the delay, how long data is sent. And the last option allows you to enable sending duplicities. In the end, if you will enable it, you will get multiple readings in Loxone or any other software, and this is something I don't suggest you to do, so leave the line like it is now. And the second one is the pulse mode. You can basically define just pin to be used. As a default, it's pin number 7. You can also define if to use duplicities. Again, I don't suggest you to do that. This mode is really useful if you have multiple readers and, for example, multiple doors, and you need to somehow link the correct reader to the correct door to open it. So you can use this pulse output. Then we can continue to the DB mode. This has 2 digital outputs. One is when the reading is fine, the card is correct. The second one if the card is invalid. You can also define your master cards. These are the cards that are hard-coded in the software, and you can use these cards in the next mode, in the learning mode, to program the new slave cards that are stored in EEPROM. And again, you can enable sending duplicities. I wouldn't do that. And a few words about the learning mode. It's using 1 digital output. This is now as a default pin number 4. You can connect it to some LED light. It goes on for 1 minute. And when you read the correct card that is learned and programmed through EEPROM, it flashes 3 times. To enable the learning mode, you have to put the master card over the reader for defined time. As a default, it's 10 seconds. You can change it here. And the device stays in the learning mode for 1 minute. Again, if you need to, you can change it here. The cards are stored in an EEPROM. 1 card takes 8 bytes. So if you are using standard Arduino device, you have 1 kilobyte EEPROM, so it's defined here that you can store there maximum 100 cards. So these are the modes, and let's scroll a little bit down. I want to show you the logic how the data is sent over OneWire. all important stuff is shown on these 4 lines. If you are using NFC, you could have MyFair Classic, which has 4 bytes. If you have MyFair Ultralight, then it has 7 bytes. On the other hand, DS2401 has 8 bytes, and first of them is defined for family code, and the last one is a checksum. So there are just 6 usable bytes. So for MyFair Classic, it's really easy. So it's possible to put whole card in the DS2401, and we have to use 2 bytes as a padding. For MyFair Ultralight, situation is a little bit more complicated as it doesn't fit into DS2401. So I have to skip 1 byte, and I decided to skip the first one, so we have just bytes from 1 to 6. It seems that we are good to go. Let's load the code to the module. I'm using Arduino Nano. In my case, it's connected to COM port number 5. Let's try to compile it. And load it to the module. I'm also opening the serial console to see some debug information. It has been successfully loaded, and you can see that my EEPROM contains 1 card. I have 3 NFC cards lying on my desk, so let's try to read them. This is the first one, second one, and the last one. So you can see that we have the reading from the cards. Now it's time to switch to Loxone config and add our new cards. Select your OneWire extension and run OneWire monitor. Let's try the cards. I'm placing the first card on the reader, second one, and here comes the last one. Now we can add our new NFC devices. Select the first one, name it for example NFC1, create a device, select the second one, NFC2, and the last one NFC3, and create a device as well. Here are all your NFC cards, and simply drag them to the Loxone plan you have and use them as you wish them to be. So this was really easy. Now we can check out how the digital output works. You can see that I'm using 4 different LED lights. If I name them from the left, then the most top left one is the one for learning mode, then next 2 green and red one, these are for validation mode, and the last yellow one on the right, this is used for pulse mode. Let's use the master card and place it over the reader. You can see that the green light was shown and also the right yellow one. Let's use some other device. For example, this NFC key fob. I'm placing it over the reader and the red and yellow light was shown. Red and yellow. Let's try the third one. This is again the NFC card, also red and yellow light was shown. Now we can program a new card. Let's place the master card over the reader and wait 10 seconds. Here comes the learning notification light, and the card reader is now expecting us to use the new card to be programmed. So I'm using this key fob. Let's place it on the reader. 3 flashes and the key fob is programmed. Let's try it. Green light and yellow light. Again, the same. Let's do the same thing with the last card. You can see that it's not known. So I'm using the master card one more time. Wait 10 seconds. Device is again in the learning mode. If you will not do any action in 60 seconds, the device will fall back to the normal state after this time. But this is not gonna happen now. Let's place the new card on the reader again. 3 flashes and the card is programmed. Let's try it. You can see green light. So this is our new setup. We have programmed that all 3 NFC devices will be accepted by our new reader. I hope you enjoy this project. I plan to do some further development to it in the future, for example add support for rolling codes. So stay tuned and see you soon. Bye!